And we're going to hear today from Canonical as they get us started with
This
Edgex.
meeting is being recorded.
Is getting started with Edgex and snaps. So we really appreciate both David Beaumonte and Farshid Tavako-Lizada. Boy, I hope I didn't completely cream that, Farshid, as our presenters from Canonical today. With that, gentlemen, I'll turn it over to you.
Okay, thank you very much, Jim. Yeah, as you have said, we are going to introduce today how to get started with Edgex as a snaps. Today with me, it is Farshid. Okay, he is the engineering manager of Edgex, and I am David Beaumonte, and I am product manager for IoT and embedded software products at Canonical, including Ubuntu Core and hardware certification, but also Edgex. And today, what we are going to see is how to get started with Edgex as a snaps, but not only as a snaps, also running on Ubuntu Core. Okay, so we will introduce briefly what are snaps and what is Ubuntu Core, and also a brief introduction about Edgex. I think it's worth highlighting it again. And then we will go on with technical description and introduction from Farshid about how to get started with all of that. And at the end, we will have some time for questions. Okay, so let's get started with it. So this is a question that I always ask myself. Okay, so why is it so hard to have successful IoT and edge devices? Okay, so this is we find many challenges, as we will see later, and I think it's worth highlighting some of them. Okay, but what kind of devices are we speaking about when we speak about the edge? Okay, so there are many different ways to categorize or classify the devices. The first categories that we typically use are IoT and edge devices. Each of them has its own needs, as we'll see. When we think about IoT devices as single-purpose small devices that may or may not have cloud connectivity, these devices are typically sensors, actuators, or human-machine interfaces. In the edge, we find two kinds of devices. We find the far edge devices, which are the ones that are able to speak with these IoT devices that don't have connectivity to the cloud, and they also perform additional tasks and send the data to the cloud. These devices are usually more powerful machines than the IoT devices that we spoke about. The near edge, the near edge is the place where additional complex tasks are performed before interacting with the cloud, so that communications can be optimized and many tasks can be offloaded from the cloud. And one thing that IoT and far edge devices have in common is that they are typically located in locations with difficult accessibility in the field. So it is very important that they are reliable and unattended. Okay, so, and we shouldn't understand these categories as something fixed, okay, as there are many devices that are hard to categorize, and these boundaries are quite blurred. But I think that it is a very good starting point to understand what are we going to speak about, which is basically these far edge devices, which are close to the things. And what do the device manufacturers and developers in general want? They just want to focus on their application development, on their business case. They don't want to spend time and money on reinventing the wheel, and they just want to use a reliable and secure underlying framework. And once the devices are deployed in the field, they want them to be unattended, but at the same time, up to date and secure for their whole life. So let's dig into some of the challenges that most manufacturers must face to develop these kind of devices. So you know that there is a huge competition in this really fast-paced market, we could say. So reducing the time to market is critical, but also it is critical to optimize development costs so that development impacts as little as possible the final price of the products. And we want our developers to be focused on our use case and application development. So having traditional embedded software developers who are experts in porting the kernel or driver development and so on is really expensive nowadays, as they are hard to find. So yeah, these developments take time. Okay, so most companies prefer using hardware that just runs with a specific operating system and development framework. Additionally, these kind of devices are usually in places, as I mentioned earlier, where sending a technician to recover them is expensive. So they must be unattended and unreliable. Basically, unreliable hardware can ruin the business model. And additionally, security is taking a critical role as those connected devices are increasingly handling more critical infrastructures and data. So manufacturers want them to be secure for the whole life of the device in the field. This brings basically two problems. On the one hand, you need out-of-the-box security features that protect your data and firmware. And on the other hand, you need the infrastructure to detect, fix, and deploy security vulnerabilities as soon as they appear. Bear in mind that it is not only expensive to recover devices that have been attacked, but it is even worse, the damage done to the brand if your fleet of devices is not secure. But there are even more challenges for these far-edge devices. We have to integrate things and protocols. So we need to speak the language of the things. I don't know, Modbus, GPIO, camera services, these kind of things. We also want to include additional processing and intelligence. We need to, this is basically necessary to offload cloud processing or near edge processing. We also want to be cloud agnostic. Okay? We want to move to a different cloud provider easily. Performance, it is also very important to have low latency. So it is really important to have a high performance framework. And applications must be modular and scalable. But also the development framework must be user friendly because this is going to improve developers' productivity. Okay, they find something that it is easy to use. So this is basically our proposed solution to develop this kind of edge devices, which is based on Edgex running as snaps on Ubuntu Core as the underlying operating system. So let's take a closer look at each of them. Let's start with Edgex. Okay, this is a very well-known definition of Edgex, but I think it's worth highlighting it again. Edgex is an open source software framework to develop and build applications that are highly flexible, scalable, and vendor neutral. It acts as a middleware between the things and the cloud. It is hosted by the Linux Foundation and LFH, and it has been widely adopted by silicon vendors, manufacturers, and software vendors. And as I said, Edgex acts as a middleware. And what does it mean? It means that we have, on the one hand, device services that interact with the things, okay, the sensors, actuators, and so on. So these device services speak the language of the things, this GPIO, Modbus, or camera services, whatever kind of service that we want to use. We also have some core services that handle the data, provide the API, edge intelligence, database, these kind of things, and also the some application services that interact with the cloud or with other applications. So as we can see, it is very modular and highly scalable. It is possible to add additional edge intelligence and has a very low latency. So it solves many of the challenges that we saw earlier. Let's move on to the operating system. Ubuntu Core is an Ubuntu flavor optimized for IoT and embedded devices. That is, systems with limited resources in terms of CPU, memory, and storage. And what does Ubuntu Core actually offer? The first important thing is that it is Ubuntu. Okay, it is based on Ubuntu LTS version, using the same kernel and libraries, but removing all the unnecessary packages so that it is more lightweight. And as it is based on an LTS version, it has up to 10 years of support. It is fully containerized based on snaps. That means that all the applications have to be snaps that are strictly confined. And yeah, we will see that later in the next slide. There is a large ecosystem of applications available in the Snap Store. And those applications, the kernel and the whole operating system can be updated using transactional bulletproof updates. That means that if an update eventually fails, there is an automatic rollback to the previous version. Security is also in the DNA of Ubuntu Core, okay, reducing the attack surface for connected devices and also receiving promptly security patches from Canonical as soon as we detect them and fix them. And last but not least, Ubuntu Core has been certified for a large number of devices, including Raspberry Pis, Intel NUCs, and many other devices, okay, the Advantech devices, Lenovo, Dell. Certification means that Ubuntu Core has been enabled on those devices by our engineers, and then the devices are automatically and rigorously tested in our labs to check that the new system patches and updates don't break the system. Okay, and as I said, the snaps are the building blocks of Ubuntu Core. Basically, snaps are applications that are packaged along with their dependencies, so they are immutable and fully portable. Strictly confined snaps provide full application isolation. A strictly confined snap can't break the system, okay? But additionally, the system or other applications running on it can't affect or break the performance of another snap. Every snap is based on a base snap, which is a special kind of snap that provides a runtime environment with a minimal set of libraries that are common to most applications. And Ubuntu Core is a fully containerized operating system based on strictly confined snaps. And the revolutionary thing here is that not only the applications are snaps, but also the kernel and the rest of the system. This means that all the components of the system can be managed, updated from the IoT App Store, the Snap Store. And additionally, snaps can be used across many other operating systems that support the snaps. So you can use exactly the same package in any other system without portability or dependency issues. Okay, and how do we work with Ubuntu Core? It's very simple. Ubuntu Core is not the typical operating system over which you're going to develop the applications directly. Okay, it's typically the operating system that you flash, deploy your applications on, and it just works. Okay, it is very easy to maintain, it is secure, and it is always up to date according to your rules. So the applications are typically developed externally. You can develop your applications using, for instance, Ubuntu Desktop. And as those applications are snaps, you can even test them in that system. Okay, then you can publish your applications to the Snap Store and deploy them on Ubuntu Core. It's a very simple and straightforward process. There are also ways to install snaps manually without being published to the store. Okay? The easiest way to do that is via the store. And all the information related to how to work with snaps can be found at snapcraft.io/docs. And Rashid will also dig into some of those details later on. Okay, and I'm reaching to the end of my part of the presentation. And so why should we use Edgex as snaps on Ubuntu Core? Okay, we have seen the benefits of Edgex, Ubuntu Core, and snaps individually. And what we can see is that altogether, they solve all the challenges that we introduced at the beginning. They are developer-friendly framework to develop easily high-performance, modular, vendor-neutral edge applications. They allow you to focus on your application development and so reduce development time and costs. And what is more important, to accelerate your product time to market. It is a secure and reliable framework. And so you benefit from an operations and maintenance cost reduction. And it is supported for up to 10 years. So yeah, here I'm going to hand over to Farshid.
All right. Thank you, David, for the introduction. Let me share my screen. So I would like to share my entire screen, but it may be a little small. So let's give it a try. So is this too small for someone in the audience? Maybe you can give me feedback.
Attendees, if you could just use the chat window, just put a little thumbs up or can't see, or give some indication as to whether or not you can see things on Farshid's screen right now.
Or Jim, how about you? Can you see things?
Yep, looks good to me, Farshid. I can read it, and I have bad eyesight. There is somebody, Mengi, saying if you could make the terminal just a little bigger, that might help.
All right, I will do that. Sometimes it doesn't work, but sure how this gets bigger. Okay. All right. Let's get started. Perhaps it's too big now. So yeah, David gave an introduction of why snaps are useful, what is Edgex all about, and here I'm trying to provide a technical introduction for getting started with snaps. If you have been in the Edgex community, you may already be familiar with the Docker deployments, how we use Docker Compose, and you may have also heard that that's probably the easy way when you want to deploy Edgex. And I'm here to tell you that, okay, there is an easier way that we can use to deploy Edgex component, and it provides additional benefits out of the box. So in this walkthrough, I will show the steps for deploying a bunch of snaps, Edgex snaps, which provide the capability to collect data from an Mqtt broker and store it inside Edgex. Now you can then do further processing, you can visualize it, and you can do anything that you can do with Edgex. I will show you that there is already a device set up which is producing data, a very basic device. And then after we have all of this stack available and configured and ready manually, I will show you how we can create an operating system image, which is preloaded with all of the components that we show beforehand. So then you would be able to just flash it on whatever number of devices that you want. And then they will just come with this stack that not only are already started and running, but they also get updated over time. You don't need to go back and manually change stuff. Yeah, so I think the starting point for all of these, if you want to try to do this manually, would be just to refer to the Edgex documentation. Here we have getting started for users. Then we have this page for getting started using snaps. And then it walks you through the concept. So if you look at the table of content, it shows you how to install stuff, how to configure them. There are a few different ways you can configure snaps, depending on the use cases. And then how to manage those services, how to do debugging, and then specific configuration steps for individual snaps. Now, let's just very quickly browse through it. So installation of snaps is usually available using the snap CLI, assuming that you are on a Linux distro that has a snap installed. Then you can install a snap. There are various channels for snaps. David gave a brief introduction to that. And the channels are basically tracks that host different revisions of snaps. So you can have a latest stable. And if you install from this channel, you are going to get follow-up updates that are stable from the latest version. You can follow a channel which is for LTS, for example, 2.1, and then you would only get the updates for the LTS. And you can also follow a channel which is for the cutting edge releases, and you would get those things. It's pretty simple stuff. Then we go to the configuration. Configuration files are usually locally available on the device, and you can just go to the directory where the snap is and find the readable, find the writable data related to that snap, and then you can edit it. There is also another directory which the read-only files are hosted, for example, executables, example config files, and so on. But you don't want to really touch those. Those are just for the package itself. But everything that is on var snap is editable by the user, and this is what you want to know about. You can also change configurations from the Edgex registry, which is console. So once you have your system set up, you can always refer to console and change some of the configurations that are supported. Another way of configuring snaps is using config providers. At the end of the walkthrough, I would briefly talk about this, which basically allows packaging of configurations. So you can ship your application, and you can also ship the configurations. And then last but not least are configuration overrides. These are kind of equivalent to environment variables, which allows you to override configurations that are passed using one of the other methods mentioned previously. And we basically have a one-to-one mapping with environment variables. And if you refer to other parts of this documentation, you may see information on how to set environment variables, which map to configuration fields in the config files. And we also have another mapping for the snap. So you should be able to just look at the configuration file and figure out what the equivalent snap option is you can set, and then the device is going to pick it up after a restart. Moving on, then we have ways for disabling security if you are demonstrating it. Today we will demonstrate, but we are not going to disable the security. If you want to manage services, there is a CLI subcommand for it where you can just use it to enable and disable. So when you enable and you restart a device, the snap is going to be started automatically after boot. This is equivalent to if you have a restart policy for the Docker container, or if you have a system file which is set to be enabled. If you want to debug your snaps, you can query the logs. It's almost as powerful as journal.ctl or Docker logs. And then last but not least, we have the documentation that are specific to the snaps themselves. I'm not going to go deep into it, but it's just to tell you where they are. And everything is there if you want to refer to. Now, with that said, let's go back to the walkthrough. We will go through setting up the stack, which includes a Raspberry Pi 4 running Ubuntu Core, the ARM64 variant of it. It has a host name called Jupyter, and we will refer to it in the next step by the same name. We will run the Edgex stack, which is like the core components, the security components, and a bunch of device services or any other tool that you want. We run it on this machine. And then we have a Raspberry Pi 0W, which is actually currently in a bedroom in my home. And it is connected to a DHT22 sensor. If you don't know what that is, this is a very simple sensor, which is probably available in any geek's home. So you should be able to set this up very quickly and try it out. We use a bunch of tools, which are not strictly about Edgex, but we need them. So first is Mqtt, which is the Mqtt broker. The data is being published from the Raspberry Pi 0 with the name Pluto, is being published to the Mqtt broker. And then we subscribe to it from Raspberry Pi 4. We use the Edgex CLI, which is wrapper for Edgex REST APIs. And as an alternative to this, if you want to go more advanced, then you can use an HTTP client. We provide examples for HTTP Pi, but you can use curl or anything else. We use YQ, which is similar to JQ, but for YAML. And we use it to validate files or convert them to JSON. And lastly, we use Ubuntu image, which we use in the last step to create the Ubuntu Core image. Now, let's get started. So to install the platform snap, you can just simply refer to the store page. Let me just zoom in. There is a description of what this is about, but what is the most interesting part are the channels. So you can see that there is 2.1 stable. So if you want the latest LTS, then this is where you would go, and this is where the command that you would use. But in this demo, we just take the latest stable, and that's the command we'll execute. Now, I wasn't sure how stable my connection would be, so I've already installed it. And we can see, let's check which version is installed. Oh, that's pretty large, but okay. I have 2.2.0+2 installed, the same one that is shown here. So let's move on to the next step. Now, this is the platform. It's just a single command, and you will have it running. You don't need to do anything else. Now, if you are demonstrating, then you may hit the 1 hour expiry time for the tokens that that are deployed when you install Edgex. If you want to extend it, then you want to buy yourself more time to play around with the system, then you can execute a bunch of commands, which are again already documented in the documentation I showed you, and then you would extend it to 72 hours. But if you are going to start your other services within the first hour, then those tokens are going to get automatically updated. So you won't need to bother with this. Now, we have the platform set up, but we need to make sure, okay, there is some actual data coming to work with. We have already set up this application called Mqtt on Pluto, and it has the following configuration. It is publishing to a public broker. It has a port, and then it has a topic prefix for the data that's coming in. It has a client ID, the pin that the sensor is connected to, the type of sensor. It could be DHT22, 11, or 21. And then there's the interval, which is how often is it querying that device to get the reading and publish it to the broker. Now, as I said, this is already set up, and I can just execute this command to subscribe to the public broker, and with this topic wildcard, I should be able to get the data. Now, I am going to put this command in the chat, so you can actually subscribe to it right now and just get the data that I'm about to get. Now we immediately got 2 measurements because this was retained. But if you wait long enough, I think my current setup is actually 60 seconds interval. So if you wait long enough, then you would be able to get more data. And we will come back to it later. So I'm just going to leave it open. Now you can see the topics has 3 sections. The first section is actually the prefix. The second section and the third section are very important for our use case because the device service that we are about to use in the next step expects the device name and the resource name to be in the topic. There is another way of wrapping the payload in an envelope which has all of this information, but we are just going with a simple form, and we need to provide this in the topic. So yeah, another one is here already. That's a good sign. So data is coming. Let's move on to install the device Mqtt service, which is basically connecting to the platform, subscribing to the broker, getting this data, registering whatever device and profile is necessary, and then ingesting this data into the platform. Let's go back to our device. I'm going to make this a little smaller because I can't see anything. It doesn't work. Not sure how this works, to be honest. Okay. So let's install it. This one should be installed in a few minutes, in a few seconds. While this is being installed, just some background. The device service snaps are not started by default because in most cases you would want to update the configuration before you start it for the first time. Otherwise, the configuration is going to be uploaded to the registry or to the Edgex core metadata, and then it will be more difficult to update. So let's just get in there and update our configuration before we start. We have a configuration toml file. We have 2 directories, devices and profiles. Inside devices and profiles, there are some default configuration files which come from the source of the project. Now, if we started, these things are going to get uploaded, but we don't really need them. So let's just remove them to have a clean start. Ideally, they shouldn't exist, but they do. They are still available under the read-only directory if you want to refer to it. So instead of var snap, which is where we went just now, we would just call it snap. This is read-only and it's the package. And this is bind mounted from when you install the snap. So you cannot really edit it, but it's there when you install, and it's going to basically go away when you remove the snap. So let's create a profile. which is basically describing our resources, and then we will add a device which is using that profile. So we would call our profile temperature humidity sensor because that's the sensor we are using. Let me see if this is going to work. And then we copy it. And we practice our JQ, our V skills. Okay. So, okay, this one is in. And then we add a device. Now, the profile we just added has two resources. One is temperature, another one is humidity. These are basically what the sensor is providing. So if we go back to our measurements coming to the broker, we see, okay, there is a humidity, 41%, temperature, 26. That's why you hear this fan noise. Maybe Zoom is filtering it out, but it's pretty warm right now. And we are defining it here. So the value is float, and we are just allowing read. You can also allow writes, but it doesn't make sense in this case because we are just sensing. We are not actuating anything. Now let's create our device. The device is called Pluto DSG22. Command not found. And this is the name of the profile we just created. So the profile needs to exist, and then this device can use it. Okay. Let's just check my profile again. Okay, everything is good. Okay, we have our device and we have our profile. Now we need to also update the configurations of the server. So if we look at the configuration TOML file, we would see that there's a long list of items that can be edited. Let's just take a look at it here. It's right here, and there is a lot inside. And we need to update 4 entries. One is the address of the broker. This is the public broker we are using. There is a client ID by default, which we need to remove. Otherwise, if multiple people are running with the same client ID, then the broker is going to start kicking out some others. So when we remove it, then the Mqtt client automatically generates a random one. We need to set topic levels to true because, as I mentioned before, we need to make sure we support topic levels and extract some of the metadata from the topic. And this is the prefix for our data. Now I can just go to the configuration file and edit these, or I can use the snap overrides, which is quicker, probably harder to type, but they are quicker if you know what you are doing. Let's just copy paste and let it do its thing. So all done. I can actually get it and see what I've just said. This is, I think, pretty useful if you are debugging. And then you can pass the -d to get the whole object. So you can see that it converts to a JSON object. You could even set the JSON object. So instead of setting these things one by one, you could just pass in the entire object and it would just have the same result. Or you could call the command once and combine all the arguments instead of multiple commands. But I'm just putting it here like this because it's more readable. Now, everything is in. We have our device, we have our profile, we have our server configuration, and we are ready to start. Now, this is started. I can get the logs to make sure there are no surprises, hopefully. I don't see any error, so that's a good sign. Then we will move on. So if there were some errors, then we could enable debugging, then we could restart it and then get the logs, which would include the debugging information. And if at some point you, I don't know, messed it up, if you had some wrong configuration and it got uploaded, and for example, for the device or profile, the solution would be to just delete them from core metadata. And here I have examples how you can delete it using Edgex CLI, pretty simple. And it has error handling. So if you try to delete this profile, it's not going to work because we have a device which is associated to it. So you need to first delete the device and then delete the profile. You can also call HTTP endpoints if you are familiar with that endpoint. Now we have this setup. Data is coming in, and the device service we just set up supposed to forward those measurements to Edgex core data component. It has already forwarded the registration for the device and profile to core metadata. Maybe we can just check that. Device list, maybe. Yeah, so we can see, okay, there is a device already registered. And if you do device profile list, then you can see, okay, the profile is also there. Now, let's see if there is data. We can use the same CLI, device reading list, and then you can put the limit or no. But you can say, okay, we have already collected some measurements. Let's count it. Yeah, we have already collected 8 measurements. And yeah, I call that good progress. So far, so good. We could also query the JSON using the same CLI. Let's see if it works. Yeah, it's a little messy. But instead of that, we could also use the HTTP which formats the output for you. So I don't have JQ here to format it. Otherwise, I could use curl combined with JQ, but HTTP just gives you the formatted output in JSON. Now we have everything there. Data is coming in. We showcased how to quickly set up this environment with snaps, which if I wasn't really explaining it, you could probably do this in, I don't know, 2-3 minutes. It was fairly simple. You can also set up Grafana dashboards to collect this data if you want. So I haven't included the instructions in the README, but this is fairly simple to set up. If you use the JSON API plugin of Grafana, it's pretty small, sorry. If you use the JSON API plugin, then you should be able to query data and just show it on a dashboard. And it doesn't work right now for whatever reason. But yeah, so the data is coming in. You can see it, and it's probably a configuration issue somewhere, but you should be able to see the time series data coming in with very minimum configuration if you want. And this is queried directly from core data. Now, moving on, let's go back to our document. Let's just do a recap. What did we do? So let's do a snap list. Again, this is pretty ugly because I have zoomed too much. Let me see. Okay, so this is better. This is what we installed in the beginning. It was already installed. This is the device Mqtt snap, which we installed and configured. You can see the track, you can see the revision. This is the Edgex CLI, which we were just using, the Grafana, which we were just using, HTTP, Mqtt, everything is there. And we are on a RAS, we are on a Pi. Now let's create an open operating system image, which just comes with this. So we did a bit of manual work to set this up. And if you are setting up a real production environment, then it's going to be much more demanding, and you don't want to repeat all of these every time. So we would just create an image which comes with all of these. There are different pieces into the image. So first of all, we need to provide configurations which are packaged. So we cannot go and edit this configuration, or we cannot just put files alongside the image which can be pulled in. Instead, we need to package our configuration, basically the 3 files that we just worked on. And we need to create a snap out of these files. Now, the source code of this is available here. It's fairly simple. I have device MQTT resource. Exactly what I just worked on is placed here. And I am creating a snap out of it, which is just dumping all these files where they should be and providing a slot where device MQTT can connect to consume this file. So this is kind of equivalent to Docker volumes where you mount a volume. Here, this directory is mounted on the consumer side. Now, I have already built this. I have already submitted it to the store, but it should be fairly simple to do. You can also build it for other architecture using remote build subcommand for Snapcraft, and then it's going to just build it on some build farm and give you the answer, give you the result. Once you have that, then you can create a model assertion, which is basically describing what should be in your image. You describe what is in the image, and you need to sign it so that somebody else is not going to come and modify it and submit it on your behalf. You need a signature to do it. These commands help you to set it up and register your signature to the store, so it's associated with your accounts. And then you can create the model assertion file. Now, the model assertion has your developer ID, it has architecture, it has a model, in this case, it's Ubuntu Core 20, which base is using Core 20, and then what snaps are included. Now, we have a gadget snap here, which we will build later on in the next step, and this is responsible for making sure snaps are connected to each other in the right way, and making sure the default configurations are set. We have the PC kernel, which brings the kernel resources for an ARM64 base. So this PC, if you were creating a model assertion for Pi, this would have been Pi kernel. And there is also, this information is all available in the documentation. Then we come to the Edgex part of it. So we have Edgex Foundry snap. Again, we have the default channel. This is the ID of the snap, which you can easily query using snap info command. This is the device MQTT. And then this is our config provider, which includes the configuration I just explained. Now, moving on, so the file is ready, then we sign it. When we sign it, then there will be an output called model signed YAML, and this YAML file is going to include the same model, but also your signature. So you can see, okay, I have already done that step. I have these things, and I also have the signature. So this is almost ready for creating an image, except that we don't have the gadget yet. And that's why we have the next step. Now, as I explained, the gadget is architecture dependent. So if you plan to create an image for ARM64, then you need to use an ARM64 gadget, for example, for a Raspberry Pi. If you are creating AMD64, this is what we are using, then we use the PC gadget. If you refer to this repository, then you will find a list of files. What we are interested in is gadget.yaml only, and we need to append this information into it. Now, what this is. So first of all, there is a connection, which is basically telling the snap daemon that the provider which we created should be connected to device MQTT snap. And that's basically what it is. So the plug is connected to the slot, as simple as that. Now we can also pass defaults. So I showed you how we can configure the device MQTT using options, but we ended up providing a config provider. Now we could also provide those default options here. In this case, we are just setting auto start to true so that the snap is started automatically, because the configuration is already available compared to what we did manually and we had to start it in the end. So we do this, and then we can go ahead and build it. But in favor of time, I won't build it. So once you do this, you call snapcraft command, and you are going to have the snap ready to go. Now going back to our model assertion, we had already signed it, and we need to build it. But this gadget snap is not available on the store, so we need to sideload it. So this is the command we would use to build our image and tell it that you need to get a snap from a different address. Let's do it. So I've already built my snap, but it's in a different directory. Let's see if I can get it to work. Yeah, okay, it's not here. Okay, so this is our snap, yeah. And then we call this command. So it's gonna start fetching what is needed from the store, including snapd. So this is the daemon that takes care of snap runtime, and it's pretty slow right now, so we probably won't be able to show all the steps, but basically it's gonna go through them one by one. And this is the output. Snapd, the kernel, everything that's supposed to come from the store will come. And then you have a warning here telling that your gadget is disconnected and it's not gonna get updates, obviously, because we just sideloaded it for this demonstration. But ideally, this would also come from the store. And then you would have a PC.image that can be easily flashed using any tool that you like. And I'm going to interrupt this thing. And instead of flashing it on a Raspberry Pi or on an ARM AMD 64 platform, I will instead run it in an emulator, because then it will be easier for me to demonstrate. Now, this is my command. It's pretty long. I don't understand most of it, but neither should you. So the only important part is to make sure you are passing the right image. And let me see, where is my image? So I have this PC ready. PC ready. We'll just pass this. PC ready. And then you will see that something is happening. So it's booting. Let's give it a minute or two, and then you are going to have this whole stack ready to you. So this command included some port forwarding configurations. So it's forwarding the port 22 of the virtual machine to port 822 of the host. And this allows me to SSH into it once it's ready. If you want to access other ports, then you can add more of these. And yeah, you can already see there are some Edgex logs. You can see, okay, subscribe to this. And looks like it's already doing its job. So let's SSH to it and see exactly what is happening. I will interrupt the subscription, and I would SSH to it using my username. So this running virtual machine has already pulled my public key from the store, because when I built it, I provided my information I provide my user information, basically. So let's see. This is an Ubuntu Core instance. It has this snaps installed. Basically, exactly what we wanted, except that I have also an HTTP, which I installed for the sake of debugging. I can also install anything else I want. For example, I can install Edgex CLI, which doesn't come from the OS image, and it shouldn't. But now I'm trying to do some debugging, so I install it, and I can just query reading doesn't work. Yeah, not sure what the command was. Okay, let's go back. I'm pretty sure it was reading. Oh, it's reading list. Okay. Yeah, so you can see, yeah, because I already had this running, and previous to this call, I was playing around with it. There is already a lot of data. But yeah, this is a live image. You can build exactly the same thing by following the command that I just showed you. And then you would have this whole stack. And you can also see the connections that we set up. You can see, OK, this config provider here is connected to my device MQTT stack. Exactly as I wanted it. No surprises, no strange behavior. Exactly how we define the model assertion, and then there we have it. And that's about it. So we went through setting up Edgex manually, and we saw how easy it was, arguably, using snaps, how easy it was to package them, how easy it was to install them, configure them, and then how easy it was to benefit from them for creating an OS image, which can easily be flashed or run in an emulator to do further debugging. Let's see if I have any questions.
Okay,
but David,
I think that I can make a wrap, and then we can go to the questions. Let me share my screen.
Yeah, I'm going to stop sharing now.
Okay, very briefly, let's see if we can have also some time for questions. What we have seen today is what Ubuntu Core and snaps are. We have also reviewed what is also Edgex, but we have focused on Ubuntu Core and snaps. Why Edgex is running as a snaps on Ubuntu Core are important. Okay, what are the benefits that we are going to have if we use Edgex running as a snaps on Ubuntu Core? And Freshit has also shown us how to get started with Edgex as a snaps and Ubuntu Core. Okay, so and also showing us a demo of that. Just I would like to say that in September we're going to have in-person workshop, okay, organized by Intel and Canonical. And I think it would be very interesting for people who are interested in getting more deep knowledge about all this stuff, about how to use Edgex as a snaps and Ubuntu Core. So feel free to reach out to us and register to this in-person webinar, workshop. And now it is time for questions. I don't know, Jim, how much time do we have for questions? And if we usually have the questions in the chat box, or if people should mute their mics, or how this works.
Yeah, David, so we do have one question that's come in already over the question and answer screen. We've got a question that says, for security, how secret tokens have been exchanged by different Edgex snaps? Do users need to set up a token each time?
I think that this is probably a question better for Freshit.
Yeah, so there is an interface between snaps, which works in a similar fashion to the config provider, which I showed. And this allows secure exchange of tokens on a local machine. So when you install your device service, the device service connects to the platform snap, and it receives a token from the platform snap. So the users, they will not need to set up manually anything. As we went through, I did not set up anything manually, and the token was provided automatically.
Thank you.
Thanks, Farshid. Giving folks a little bit of a chance here to ask any other questions via the Q&A or the chat panel. And while we're waiting for that,
I think that there is another question. I think that there is a question in the chat box, not in the Q&A.
Yeah, thanks, David. So if I wanted all my sensor telemetry information to come from removable storage, what would be the recommended process for that? Farshid, that's the question from Jim Cogswell.
I'm trying to understand the question. So the sensor, so is it about the metadata of the sensor or the sensor data itself? The metadata, I asked you.
Just should probably make an assumption and answer the question.
Yeah,
let's.
So if it's about metadata, I believe that you can have a removable storage, and you can set up the gadget in a way that it gets this data from the removable storage. Could be a USB drive, and then it would provide it to the snaps. If Tony is in the call, maybe he can give more details about this.
Hey, can you hear me?
Yep, we can, Tony. Yep.
Hey, everybody. So I think if the sensor telemetry data is on removable storage, you would need a device service that knows how to read that data from the removable storage. I'm understanding correctly. If we're talking about like the values from the sensors, if they're being written to the file system on removable storage, then you need a device service that knows how to read that data. Does that make sense?
It does. Thanks, Tony. And Jim Cogswell, if we haven't answered your question, please go ahead and type out some more in either the QA or chat. We'll try to answer. Another question came in, Farshid and David. Can snaps be installed in different devices and talk to each other? Question from Miguel.
Yeah, well, yes. So the snaps, they are just packages. So if your applications can talk over the network to each other, so can the packaged applications.
Yeah.
There are some difficulties when doing so. For example, if you want to exchange tokens securely, that part is challenging, but the applications can easily talk over the network. David?
I was going to emphasize what you are saying. So you could even have device services on one machine and the core services running on a different machine, for instance.
Right.
Any more questions? Feel free to type them in right now. Again, later today, the recording of this talk, along with the slides, will be made available on our wiki site. I put the link in the chat window. This is also being streamed over YouTube, and it'll be available on our YouTube channel later today as well. One more question from Jim Cogswell, Farshid. When the device gets auto-updated as new software is released, am I understanding correctly that anything in the var directory will not be overwritten?
That's correct. So anything in the snap directory, which is the package read-only file, will get updated, but things that are on the user side, writable for the user, will not get updated. So your configuration is safe in place, and as long as you receive backward compatible updates on your channel, the configuration is expected to continue and work.
Just to add one bit of comment there. There are writable areas that the snap is given. There's one that's a common that's the same across all revisions of the snap, across all updates. So if you write log files to it, the log files just stay there. They're not going to get touched. But there are also revision specific directories. So when you update a snap, all of that data from that revision specific directory is copied into a new directory for the new revision. And this is one of the things that allows us to have automatic rollbacks. If that update fails, you fall back and the data is as it was, right, when the update started. But if the update succeeds, you've now got a copy of that data that's been moved forward.
Thanks much, Tony. I'd like to take a chance here to say thanks to David, to Farshid, and to Tony and all of Canonical for presenting today on how to get started with Edgex and snaps. I want to thank all of our attendees for coming in today and having a listen to this talk. If you want more additional information on Edgex Foundry, you can go to edgexfoundry.org. You can get links there to GitHub, to our YouTube site, to things like our Slack channel where you can ask other questions. We really do appreciate and hope you will continue to follow us. With that, I'm going to close out today's Tech Talk. And again, thanks to all the panelists and participants, and we'll talk to you all soon.
Thank you very much.